And get ready, I'm going to do the countdown, Marianne. 5, 4, 3, 2, 1.
This meeting is being recorded.
Thank you, robot voice. And that was Marianne. Good morning, everybody, and welcome to our Saturday morning class. It's the 12th of August, and I'm fortunate, load shedding just finished, so my internet should be up and running. Great. So we're going to continue with last week's exercise. Last week, we spoke about assessment 3. Marianne, just give me a quick recap, Marianne. What did we do last week? It was assessment 3. Which question did we answer?
I think it was question 1, sir. I'm trying to cast my mind back now.
Yes, yes. We were talking about a string.
Yes, it was string length. There we go.
Right, string, and we spoke about the size of a string. And Abdul's not on the call right now, but he mentioned that we could have used another function in order to calculate the number of characters in a string. So today we're going to continue with that. We're going to go to, let me just do my share. Let's see if we are sharing the right screen. So there we go. I'm sharing the assessment 3. Assessment 3 is due I think in September. We've got some time out there, but we need to ensure that we understand all the concepts involved. So today, if it's okay with you, Marianne, I'm going to talk about arrays, because that's in question number. Let me look at which question that is. Arrays is in question 8, right? Question 8. They're talking about arrays. That's a 2-dimensional array, and prior to that, they're talking about a 1-dimensional array, which is question 2, right? So question 2 is 1-dimensional array. And I'm also going to talk about the reference parameters. A reference parameter, because that's a very, very important question, right? And a concept. That question is, that's too far, I went ahead. I'm looking at assessment question. It's question 5. Right, so let's do that. And let's see if I can do it, work in about half an hour or so, because I don't want to overwhelm you. Right, so let's look at arrays. So here's my array. I'm looking at, let me share my screen, split my screen in 2. So this is a technique that you can try as well. So you see your question on the left-hand side, and you see your code blocks on the right-hand side. Let me reshare my screen. Share. I'm going to share my screen. Marianne, please tell me if you can see the assignment question on the left-hand side, and on the right-hand side, you should be able to see my code blocks.
Yes, it seems that way.
Great. Great. So here's the question, right? In question number 2, it says, given the array declaration below, what is stored in numbers subscript 2? Int numbers 5 equals 1, 2, 3, 4, 5. So, Marianne, if you look at my right-hand side, I have an array declared in line number 5, int numbers 5. And Marianne, talk to me about the data types that is stored in this array, Marianne. Firstly, tell me how many are there?
Int numbers. Okay, so it's integers, and it looks to me like the number in the brackets is a 5, so it is an array consisting of 5 integers.
Right, correct. So it's an array, all of them integers. So you made a very good point. You said 5, so that goes towards the characteristics associated with an array. An array is a data structure because we're storing data in there, right? I'm giving you a simple definition. And you told me 5. So we got to, declare upfront that we have 5 either integers, characters, float, strings, or whatever. So that's another point. So if you notice, it is a definite number. And you also mentioned to me that it is integers. So 1 is an integer, 2 is an integer, 3 is an integer, 4 is an integer, 5 is an integer. So to put all of them together, an array is a data structure. I like to use this word, homogeneous, right? Or homogeneous, right? Homogeneous, all of them are the same. There's a definite starting point, definite ending point. And I'm going to add to that, Marianne, if I want to access an array, I access it by means of its subscript. So taking that into consideration, Marianne, if I look at line number 7, 8, 9, 10, this is where I'm accessing every single element of the array, right? So what I'm going to do right now is I'm just going to comment that out for you so that we can just talk about what they expect of you in the assignment. So in the assignment question, they want you to know what is stored in numbers subscript 2. So I'm going to do this, Marianne. I'm going to say numbers. Now, I don't answer assignment questions. You know that, Marianne. So I'm going to say assessment subscript 4. So this makes for a nice quiz question. Let's go and compile that. All right. Marianne, what have I done wrong? Oops, wrong way.
So it's something there, but I think it's the arrow.
Yes, the arrow is right. Go ahead. All right, so Marianne, I compiled it. It seems to be okay. Let me just view my manager, view my logs. Oh, I don't need the manager really. All right. So Marianne, talk to me, Marianne. What would be displayed? Numbers subscript 4.
5.
So, how did you get that, Marianne? Talk to me.
Because in an array you start counting at 0. So
Correct.
0, 1. So
right, correct.
It's fine.
All right. So let's see if Marianne is correct. Run the program. Perfect, Marianne. Right. 5. Now, Marianne, if I want to access all the elements of the array, I will use a loop to do that. And the loop that I'm going to use, Marianne, is a for loop. I mentioned this to you last week, Saturday. All right. And the reason why I got to use a for loop, Marianne, is that, remember the definition of an array? An array has a definite starting point, a definite ending point. All of them are the same. And if I want to run through all of them, I need a loop. And the loop that I'm going to use is a for loop. You could use a while loop, but this is quite simple, right? So let's quickly do a revision of a for loop. There's my starting point in my for loop for I equals 0. There's my ending point. Now, if I start at position 0, I got to end 1 less than 5, 5, right? But if I had to have it at starting at 1, then obviously I'm going to have it running to 6, right? 6 minus 1 is 5, right? But we count from 0. That's the other thing you would have noticed when our loop, right? We count from. The other thing you could have done in a loop is if you have less than or equal to, and if you start at position 1, which we're going to try now, and you'll see what happens with that as well, right? But for now, we leave it as is, I++, and there's my single line, line number 10. Now, let me give you another hint for the exams. In the exams, because it's only one line, they tend to leave that out, Marianne. And guess what? That's fine. That's okay as well. Right? If I run the program, it's still going to compile. Everything is okay. No problems with that. But this will only work if there's one line following the for loop, right? It will only work if there's one line following the for loop. So I'm going to take that out. You would be able to now answer question number 2 based on what I have told you. So obviously you're coming for my Saturday classes, not just for, learning one fact. You need to learn more facts there. So let's run this program. Let's run the program and see what happens. All right, so there we go, Marianne. As I mentioned to you, it's giving me 1, 2, 3, 4, 5. 0, start from position 1, 2, 3, 4, 5. Right? Cool with that, Marianne?
Yes, sir.
Right, great. Now, this is where I'm not requesting the person to enter in any values into the array. I'm simply displaying what's in the array, right? So I'm going to leave it at that because I want to move on to the next question. The next question, question number 3, they spoke about how many loops are necessary to access the contents of a one-dimensional array. I think if you look carefully at what I have written in line number 7 and 8, maybe that'll help Marianne to answer that question. Okay. Right, so let's just go back to what I pointed out earlier about having a loop. Right, so there's another little, I'm going to put that on and doesn't affect the output screen. Marian, you cool with that? Line 8 and line 10, where I have curly brackets. No curly brackets,
Yes, sir.
but only if it's one
Yeah.
line. Right, so let's go to my left-hand side of the screen. Oopsie, page up, page up, page up, page up, page up, page up. Page up, page. Right. So I'm going to leave out question number 4 because that deals with structs. But if you look at my quiz, you'll find it there, right? Question 5. Let's look at question number 5. What is the output of the following program? Include IO stream using namespace void func int. Right. Now, oopsie, what have I done? Right. So let's go to this side. So I'm going to say goodbye to this one. Now, unfortunately, I can't do my old-fashioned copy and pasting, Marianne. I think ma'am caught up with me, so she's int main using namespace. Right. Let's do the old-fashioned void. FUNC, that stands for function. She's written func in small int. There's my epsilon and comma int y. So there's 2 parameters out there. And inside my function, x is equal to x minus y. Y is equal to x multiplied by 10. And in my main program, int value equals 7. This is my function call. Value, comma, value. I'm passing across 2 parameters, Marianne. See out value. I'm now passing across the, well, displaying values at a comma, value, value, and use that backslash n, right, and return 0. My typing speed has slowed down now, Marianne. Let's
what I would say, you've got other strengths as well, at least. Power of the mind.
Thank you. Right, so there we go. Let's compile this. Let's see if it's int stray. Oh, it needs a little. Is it a single comma or is it a double comma? Oh, okay, there we go. Single, right. Let's see now. Yay, right. So, I don't do assignment questions, so I'm not going to use value equals 7. I'm going to say value equals 10, right? Now, let's run the program. Let's run the program and see what happens. Compile it, and we'll talk about it and as my story sum, right? Build and run. And it's given me 0, 0. So let's see what happened in this program. In this program, there's a function. If I had to, remember my story sums where I talk about once upon a time, there were 2, let me just close the door. My dogs are barking there. And, yeah. Right? Okay. So, yeah. Right. Here we go. Once upon a time, there's a function in line number 3. There are 2 parameters. One is a reference parameter x and value parameter y. Inside the function, you have x is equal to x minus y is equal to x times 10. Int main in line number 9, I have a value equals 10. I'm assigning a value and I'm passing across 2 parameters. Now we want to find out what is happening here with this void. What's the meaning of the word void? And if I had to have return x, y, and so forth. Then I ran the program and it gives me 0, 0. Where did it get 0, 0 from? In order to find that out, let's go and play around with what this ampersand does. Let's go and play around with ampersand. Let's run the program again. So this is what I expect you to work on your program to find out the assignment question, because I just don't want you to display the answer, right? Let's run the program now. Run the program, and they say, hey, nothing's. Oh, look at this! It gave me a value of 10 and 10, right? It gave me a value of 10 and 10. Let me go and put the ampersand in front of there, ampersand there, ampersand there. Let me go and build and run it. Build and run the program, and it's giving me 0 and 0. How did it get 0 and 0? What happens there? When I don't have the ampersand sign, I got 0 and 0. When I have the ampersand sign in there, it gives me 0 and 0. So if you had a pencil, I should have had a pencil. I should have written 10 and 10 out here, right? So this is another technique I use, Marianne, to basically explain to students the relationship that exists between parameters. So let me take my snippet tool, SNIP snipping tool, and new. I just want to draw a little diagram out here. If I had a block there, right. So Marianne, oh, there's your name there. I should have taken that out. Let's do it again. Let's try to take Marianne down. All right. Cool there. Let's go and do another new snippet. Right. So, Marianne, if I had to draw a relationship in terms of what's happening with my diagrams. All right, so let's take another color, red. Right. So this is what happens, Marianne. Whatever happens in value is transferred across to X. Whatever happens there is transferred across to Y. How's my drawing, Marianne?
Much neater than mine is. God, I hate drawing with a mouse.
Yeah, I need to get this little pin on it, right? So that's what took place out there. And because it has an ampersand in front of it, Marianne, whatever happens there is transferred back to this value here, right? Okay, that's what the ampersand sign does, right? So it's referring to whatever transpires inside of the program. That's what that ampersand does. So if 10 and 10 was passed across, 10 goes to X, 10 minus 10 is indeed 0, and that's the value of X, which is 0. 0 times 10 is 0, and 0 gets transferred back, and that's what happens out there, right? That's what the ampersand sign does. Now, let me do it without the ampersand sign.
Okay.
Right, so here we go. I'm taking out the ampersand sign. Taking out the ampersand sign. And this time, 10 is going to be passed across to line number 3. 10 minus 10 is 0, which is the value of X. 0 times 10, which is 0. However, because I don't have a one-to-one relationship between line number 10 and line number 3, Marianne, nothing happens, right? So I'm still getting my 10 and 10, right? So let me draw. So can you see in this diagram, Marianne, there's an arrow at the bottom and the arrow on the top. Arrow at the bottom, arrow on the top. Well, not a very good arrow at the bottom, but you can see that I tried to make an arrow, right, Marianne? Cool, Marianne?
Yeah.
Right. So let's see. Let's run this program now, and it should give me 10 and 10. Yay, 10 and 10. Oopsie. So let's talk here. Let's draw a picture. Here's my here I'm drawing a picture. And this time, if I had to draw, let's take another color. Blue is my favorite color, right? So blue. No, let's not use blue, even though it's my favorite color. Let's use green, right? So green. So there's the correspondence that takes place. Maybe it goes there, and I'm drawing an arrow, right? It goes there, and an arrow. So 10 gets passed across. 10 goes there. 10 minus 10 is 0. 0 times 10 is 0, but nothing happens. Nothing happens. Nothing happens because I don't have a one-to-one correspondence between the parameters. There's my actual parameters, my formal parameters. Right? That's
Okay.
the story between the ampersand and the non-ampersand story. Right?
Mhm.
Now I'm using another I'm using one with the ampersand and one without the ampersand, Marianne. So whatever happens in line number 5 gets transferred across to value, but y, variable y, nothing happens with that one. So let's go and run this program. Let's run the program. Let's see what happens there. Okay, so let's look at this. So it says x is 0. Oh, wait a minute. Y, which is 0 times 10. Oh, so it passes across x. X is 10 minus 10, which is 0. 0 times 10. It should not have done that. Let's run it again. Let's compile that. Run that. What happened here? Talk to me, Marianne, or anybody else. Let's see what happened here. There's this one-to-one correspondence. New. In this case, there's a one-to-one correspondence. That means whatever happens with x, it's referred to in y. But whatever happens here, it just goes there. So 10 minus 10 is 0. 0 comes across to value, and value, which is y, which takes on the value from line number 5, which is 0 times 10, which is 0. But it's taking on the value of the first one. Yes, talk to me.
I think you only need to change the first one because they're displaying the same value.
It's displaying the same value.
So if it changes value once.
Yes. All right, what I'm going to do is I'm going to play around with this, right? I'm going to make this value 2, and I'm going to call this value 1. I want you all to understand what's going on in terms of the int value 2. I want you all to see the reference parameters taking place, right? Reference parameters. I want you all to see the concept. Let's compile that function. C. Let me go and run that again. Compile it. P out. Value was not declared in the scope. Int value 1.
To see that.
Oh yeah, sorry. Value 1 and value 2. Value 2. Right. Let's just quickly do it without take out the build and run. Right, 10 and 20. So that's perfectly fine. Who am I talking to? I can't see. I'm sharing my screen, so I don't know. Who's
the student from Mandini.
Mandini,
Yes.
Mr. Student Sisonka from Mandini, right? Student Sisonka from Mandini. So there's value 10 and 20. So 10 gets passed across to x, 20 gets across, but because there's no reference parameter indicated out there, nothing takes place, right? So it just gives me 10 and 20 again, right? Student Sisonka. Now I'm putting in an ampersand in front of it. When I put an ampersand in front of it, let's build and run that. We'll compile it again and run it. There we go. Right? Student Sisonka from Mandini. Check it out, right? So what happens in the function is transferred across to the main man, right? So if it was 10, Student Sisonka, talk to me. X becomes Student Sisonka.
Yes, sir.
x becomes 10. 10 minus 10 is indeed minus 10. Minus 10 gets passed across to value 1, and there's it, minus 10. Let's take 20. 20 goes to y. It was minus 10 times 10, which is minus 100, gets passed across to value 2, which is displayed in line number 12. Following me, student Sisonka from Mandini?
Yes, sir.
Great. Marianne, are you with me, Marianne?
I think so.
Right. That's my objective out here, to demonstrate to you what this parameter passing does, right? Now, let's do it where we have one with a parameter as a reference and the other one is not, right? Right. Oopsie. Right, student Sisonka from Mandini, talk to me. Value 1 is 10. 10 gets passed across in line number 3 to x, which is 10. 10 minus 10, which y was passed, value 2, which is 20, passed across there. 10 minus 20, which is minus 10, perfectly correct. In line number 6, the value of y was 20, because that's what happened there. 20 times 10, which is 200, but nothing happened with it that needs to be passed across to the main man in line number 11. Because nothing happened, it's still giving me the value of 20. Student Sisonka from Mandini, Marianne from a place that does not have load shedding.
I'll say the Northern Cape would be a good start.
Okay, we won't mention places, right? Student Sisonka, do you understand what I'm talking and what the objective is about this parameter passing, these reference parameters?
Yes, sir.
Good. What's the other case that we can have, student Sisonka and from Mandini, that I'm talking about with parameters? We had one where both of them were reference parameters. We had one without reference parameters, and we had where x is a reference parameter and is not a reference parameter, and that's a reference parameter. That's the last case that we have, right? So there's two variables, four options. One, both of them are reference, both of them are not reference. One is a reference, one is not a reference, right? So you can try that out for yourself and see what happens. And that's what will help you understand the concept of a value parameter and a reference parameter, because that's what they are testing you out here in line number, in question number 5. In question 5, they want you to find out whether you know what is a reference parameter and what is a value parameter. So if I had to have the assignment question, so oopsie, you do this. Right, I'm going to help you. Right, and I'm passing across. Oh, wait a minute. Let's make it value 1. Then you know that I'm not doing the assignment questions. Huh? Student Sisonka from Mandini, where we also have load shedding. Right. Right. How many times a day y'all have load shedding, student Sisonka?
A lot, even now.
Oh, then how you are on your phone?
Hey, it's struggling, but not too bad.
All right. So there we go. I've made it that looks similar to what I have on my assignment question. Let's run it. Hold and run. Whoa! Right. I'm not seeing that. Right. So you're gonna do that, and that'll help you answer the question. Right. That'll help you answer the question. Right. All right. Let's do another question now from the assignment. I'm going to leave out question. I've done question 5. I helped you question 5. Question number 7. How many loops are necessary to access the contents of a 2-dimensional array? Now, let's talk about a 2-dimensional array. So I'm going to say goodbye to this one. All right, let's go to my study guide. Do I have my study guide here? Yes, there's my study guide. And let's look for 2-dimensional arrays.
I suppose what would make the most sense is to have 2 for loops, wouldn't it, sir? Nested for loops.
Well,
Because then the one moves you
if
along
we
the
had
row
for
and
a
the other one
one-dimensional
along the
array,
column.
I don't know. Let me see if Marianne has any idea what she's talking about. Two follows. Let's see if she's gone that far. Let's go and have a look at where do they talk about two-dimensional arrays. Arrays as parameters. There we go. There's a term, Marianne. So let's quickly talk about the definition of a two-dimensional array. When we're defining a two-dimensional array, it's like the word says two. Huh? And you pointed out a good point there, Marianne. You said, what did you mention? Rows and?
Columns.
Rows and columns, right? So let's look at what we see out here. There we go. It got cars and got speeds, rows. There's my columns. I know when I was a teacher at school, I used to talk to my students and tell them how to remember a column was, it's holding up your roof. That's a column, right? So it's vertical. So there's my columns and there's my rows out here. And again, because it has the word arrays in it, Marianne, all the data elements are the same. Every single data element is the same. If you look at 90, 94, 102, 111, 122, 134, those are speeds. Not the speed I travel at, right? I don't know, maybe Marianne, you drive at 134 kilometers an hour, right? But students in Sisonka,
no.
Oh, you don't drive?
No, visual difficulty, remember.
Oh, okay. You are driven. Okay. Students in Sisonka, I'm not sure in Mandini what the speed limit is. Maybe is it 90 kilometers per hour or 40 kilometers per hour? Right. But all of them would be the same, right? That's the important point about an array, even in a two-dimensional array. Now, like Marianne said, if you want to access a one-dimensional array, you needed one for loop. And for a two-dimensional array, well, I don't give out answers, right? So I can't tell you that. But it gives me on page 374 of your study guide, Marianne, look at that. For int I equals 0, for int j equals 0. Marianne. I think you somewhere on the... Marianne.
I'm here. I just think you have a question, sir.
Right. What was the question there? They say, how many loops are necessary to access the contents of a two-dimensional array? Again, I don't give out answers. We don't give out answers, Marianne. This is a recording, right? So let's go and Control C. Now improve my speed in typing and copying. Control V. Student from Mandini. Check it out. Aren't I a fast typist? Right. I'm looking for a compliment. Yeah. Right. So let's talk about this array. I did another share. Marianne, can you see my screen?
Yeah.
Right. Okay. So there we go.
I'm just trying to make it something that makes sense.
Right.
I don't know.
Right. So into this. Let's do a quick build and run. What's the area? Undefined. Student Sisonka from Mandini. What's my error?
Yes, sir.
What's my error there?
Need to go down and check return.
Undefined reference in win main 16. What error is that? Build and run. Oh, wait, right here. I didn't saw an error like this. Code. Ooh, this looks weird.
Sir, you don't have return at the end.
Oh, thank you. Who was that? Hello?
Thato from Limpopo.
Who's from Limpopo?
Thato.
Bethel.
Thato.
Oh, from Limpopo. Hey, we've got Limpopo in the house. We got Mandini in the house. We got Northern Cape in the house. So she says I'm missing something out here. I'm missing a return. Where do I put that return? Let's count my number of open and close curly bracket. There's an open bracket. There's an open bracket. There's another open bracket. Okay, and I'm missing a return, she says. I don't know where the return is. from Limpopo. Is Thato from Limpopo? Talk to me. What am I missing?
Sir, at the end of your code, you haven't had it say return 0 to end of the code.
Okay, what line number would that be?
The last one, I think, like around 20 something. Like 21.
Okay, so this is
Oh, 20, just before 20, yeah. So it would be in that line.
okay. So let me just change my my checks. Let's make it a little bit smaller than I can see more. Aha. So return 0. Oh, that's what was missing there. Let's see if that helps me. Nope, nope, nope. I've got a void function then line number 7. That closes that. And that closes that. Now int main. I'm missing an int main. I'm missing an int main. There, I'm missing this. Thank you. Control C. I'm missing my main man. Control V. Let's do a compile. There we go, 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 there we go. Thato from Limpopo. How does that look now, Thato? From Limpopo.
It looks really good, sir.
Ah, thank you. And aren't I a fast typist, Thato from Limpopo? Thato from Limpopo.
Yes, sir.
Aren't I a fast typist?
Yes, you are. You are.
Ah, thank you, thank you. I'm looking for compliments over there. So Thato from Limpopo, let's go and run this program, right? So I've got Sisonka from Mandini, and I've got Marianne from. So there we go. It says, enter 6 noise levels for car number 1. So this is what happens. It takes position 1, if you can look at it, row 1, column 1. So 90 kilometers per hour. And then it has 94 kilometers per hour, 102 kilometers per hour, 111 kilometers per hour, 122 kilometers per hour, 134 kilometers per hour. So that's row 1. Thato from Limpopo, do you agree?
Yes, sir.
Right, so that's row 1. Now, in order to get to row 2, I need another loop variable, right? So it's going to insert to me, and it says car 2. If you look at my right-hand side, Thato from Limpopo, it's got cars 2 is 77, 80, 86, 94, 103 kilometers per hour, 113. Hey, they drive pretty fast out there as well. So the first car travels at, Thato?
Yes, sir.
It's, what's the car 2? What does it travel?
Yes,
what speed? The noise level.
70. The
Next
80.
one. Next one.
86.
Next one.
94.
Next one.
103.
Yes.
113.
Lovely. Let's do the next one. You're on the roll.
Okay. For car 3.
83. Yeah.
83.
Oopsie, we can't see that. Let me just move it up. All right. 94. All right.
So, okay. So you're right, your own variable.
Okay. Okay.
Okay, I'm following now. 111.
111.
121.
121. Next one.
And then car 4, 71.
Yeah.
76.
Yeah.
85.
Yeah.
96.
Yeah.
110.
Yeah.
125.
Lovely. Right. Let me move it up a little bit for you.
Okay.
Next one.
And then
What's the noise level
5,
for car number 5?
84,
Yeah,
91,
yeah,
98,
yeah,
105,
yeah,
112, 119.
119. So we now expect the program to basically have all the inputs, and we're going to start, right? Thato, we did all this work for nothing now, Thato. I can't see what happened there, Thato, right? So let me help you along. And we had one function to enter the data. So I'm now going to get a function to display the data, right? So copy that, Control C. Watch what a fast typist I am, Thato. Thato, check it out. Control V.
Yes, sir.
Check it out. Ha, Thato, check it out, Thato.
Yes, sir.
Am I fast or what?
Very fast.
Thank you, thank you, thank you. So now I'm not going to say enter data. I'm going to simply display the data. So I don't want to say see in noise data. I'm going to say see out, right? And see out, right? So that's what happens there. Let's see if that helps me a little bit now. Yeah, Thato, cool. I'm not going to say enter. I'm just going to say enter. I'm going to say, okay, we'll leave it at that, right? We'll leave it at that. And I'm going to give you a little hint over here, Thato, because I'm going to put an end line in there, right? Right. So Thato, it seems to be looking okay. Would you mind calling out those values again for me, Thato?
Okay, sir.
Right. Oh, one more thing I got to do, Thato. One more thing I got to do. Now that I've called for, now that I've written out the function display data, I've got to call it up, right? I've got to say display data, and I'm passing across an entire array, right? Thato? Thato, are you with me?
Yes, sir. Yes,
Right.
sir. Following. Following.
And so if I had to do my story sum, once upon a time, there was a main program, and in the main program, they had an array called noise data, which was a two-dimensional array. They had the number of cars and they had the number of speeds, right? And they were collecting test data or noise data. In line number 41, they went and got the input, all right? So in line number 42, we got the output. And there's my program, and I used my function to get the data, and I now went and displayed the data. And Thato is going to help me to work out the inputs for it, right?
Input.
So Thato, let's go ahead now. Thato, you ready now, Thato?
Yes, sir.
Enter 6 noise levels for car 1. Let's go a little bit faster. It's 10 to 1.
Okay.
I can't keep you here the whole day.
Okay.
90,
90, 94, 102, 111, 122, 134.
right. Next one.
Next one, 77, 80,
Mhm.
86, 94, 103, 113.
Next one.
Car 3, 83, 85, 94, 100, 111, and 121.
Oopsie. Let me just move it up a little bit so you can see that I'm entering the right ones. And for car number 4.
And then car number 4, 71, 76, 85, 96, 110, 125.
Oops, I hit a miss over there. I
And
can't go
then
back.
car
I'm
5.
sorry about that. Okay, let's go to car number 5. Yep. 84.
4, 91,
Yeah.
98,
Yeah.
105,
Yeah.
112, 119.
119. And hopefully it should give me a nice table. Ooh, okay. The table is not looking too great, but we can work on that one, right? Right, so there we go. There's our display. All right, let's try and get that display looking a bit better. So it says enter 6, it should not have said enter 6 level noise for car number 1, 290, 40. Let's go and play around with it. In fact, that's what you need to do for homework, right? Try and work around making sure that it displays it in a table. Right, right. So I'm going to play around with it, and I'm going to take that out. Let's take that out. I want to make it, Thato, you don't mind doing it one more time with me, please?
Okay, sir.
All right, thank you. All right. So all we're doing, student Sisonka, I didn't forget about you. Marian, I didn't forget about you, but I got Thato on the line. So I said, hey, let's while she's not camera shy, voice shy, we'll get her. Right. Right. So Thato, you don't mind going with it one more time with me, right? I just want to show you. Right. Let's go for it. Right. You got no say in the matter now because I'm the boss in the class. Thato.
Okay, sir. First card, 90, 94, 102, 111, 122, 134.
Oops, 122. Slowly, you know, I'm a bit older than you.
Okay, sir.
Next one.
Card 2, 77, 80, 86, 94, 103, 113.
Yep. Let me just move it up a little. Card 3.
Card 3, 83, 85,
yep.
94, 100,
yep.
111, 121.
Yep. Next one.
Card 4, 71, 76, 85, 96, 110, 125.
And
card 5.
Hold card 5, yeah.
Okay, sir. 84,
yeah.
91, 98, 105, 112, 119.
Right. Please let me see. I got 5 minutes to spare. Let me show them that it's a table. Yay! Oh, you know what? It looks too congested. We got to make it look a little bit spaced out. What do you say, Thato?
Yes, sir.
You can see that, right? Marianne, I'm sure you agree that it's all squashed up, Marianne.
Yes.
It looks very squashed up. Don't you see, Marianne?
I guess.
You guess. Come on, Marianne. It's squashed up, man. I can't see where it is. See there. Look at that. 90, 94, 102. Oh, goodness gracious. That looks horrendous.
I see. There are no spaces between the numbers, are there?
Yeah,
okay.
no
yes,
spaces.
I see what you mean.
You see what I mean? Sisonka, student Sisonka.
Looks like an ID number.
Yeah. Oh, ID number. Yeah, right. Looks like ID number. Right. It's okay. It's not ID number, but these are all the speeds of the cars. So let's go and put some spaces in there. Student Thato from Limpopo, we have to do it again, right? So let's go and put some spaces in there. So let's put a space after it displays the C out number. And by the way, Marianne, you are right. There's one loop there. There's another loop there. It's a 2-dimensional array. So will that amount of space be okay, Marianne?
Maybe the simplest thing would just be to put a tab key in between each of the things, sir. /T.
That's a cool idea. That's a cool idea. I never thought about that. That's a cool idea. So it's /T like that.
I'm not sure. I'm trying to get the thing to enlarge to that point, but I'm not really getting it there. But
okay, that'll also help, right? That /T. Well, I'm not sure. Let's see if it works. I don't know. I'm just a tutor out here. Ha ha ha. Student Thato. That was a joke.
Yes, sir.
That was a joke.
Yes.
I should know. Student Sisonka. Oh, never mind. Let's go through it again. Let's go through it again.
Okay, sir.
Aha. Tonight
Okay,
you'll be dreaming of all
1.
these numbers, right? Don't take lottery numbers with them, please. Another joke.
Please.
Marianne. Student Sisonka? Oh, okay, forget it.
You
Y'all
don't
don't
hear
get my
that.
jokes. Right,
Charlie
right.
on the chocolate factory.
Okay,
For a
thank you.
student to teach his teachers presumptuous and rude.
Hello? Charlie in the chocolate factory? Okay, let's go on. Come on, student Thato. It's 5-1.
Okay,
Don't worry, I don't have to
94.
go shopping
Okay,
today. I don't have to go shopping, so it's okay. We can talk longer.
okay, sir.
Yes.
Next value is 102,
Yep.
111,
Yep.
122,
Yep.
134.
Yep.
And then card 2, 77,
Mm-hmm.
80,
Mm-hmm.
86, 94, 103, 113.
Right. Let me
And
just move it up. Let me just move it up. Right, next card.
Okay, sir. And then card 3, 83,
Mm-hmm.
85,
Mm-hmm.
94,
Mhm.
100, 111, and 121.
Oopsie. Right. Next card.
And then card 4, 71,
Mm-hmm.
76,
Mm-hmm.
85,
Uh-huh.
96, 110, 125.
Uh-huh.
And then card 5, 84,
Uh-huh.
91, 98,
Uh-huh.
105, 112, 119.
Uh-huh. Ta-da! Check that out. Check it out. Check it out. Marianne.
Amazing.
Sisonka. Come on. Marianne, Sisonka. Thato.
It looks amazing.
Thank you. Where's the reaction over here on where's the reaction? I must put reactions for y'all. I know on MS Teams we have reactions. They're supposed to give me a cup. Marianne.
I think if you have a look through, it's next door to the chats thing. Let me see.
I am clapping.
Yes.
Oh yeah, where's the
So,
reaction now? Where's the reaction now?
There, hang on.
I'm waiting.
Do something with
I
yeah,
can't see
I've
it.
pressed the thing.
Okay, I'll take your word for it. Okay, you can clap. Then I can hear you, Marianne.
All right.
Thank you, Marianne. Thank you. And thank you for pointing out the tab function, Marianne, or not function, the tab, using \T. The \T enabled me to display it in a table. Can you see that? And it also catered for, can you see 102 and 86? It all looks nice and spaced out. Isn't that cool, Marianne?
Very.
Thato, you called out all the numbers so many times. Thato, you'll be dreaming of these numbers tonight. But don't take the lot of numbers on that, huh?
I would, sir.
Okay. So hopefully today I did another objective was to talk about arrays. We spoke about one-dimensional arrays. We did a quick entering of we didn't enter it in. It was already values were, and now we talked about the two-dimensional array. In a two-dimensional array, you need two loops, one for the row, one for the column. We took an example from the study guide on page 372. This is where I entered values into the array. And this is where I displayed values, right? I took the same function, right? The void function, get data, and I used that and I got display. Now, you could have had, if I was doing this in my full-time class, I would have done another function called calculate, where I either calculate the total, the sum, the values of a row, or all the, well, it doesn't make sense to add all the noise values, but if these were marks, if these were student marks. So if I had, instead of car 1, I would have said student 1, student 2, student 3, student 4, student 5, cost 1511 marks, cost 1512 marks, INF 1505, INF 1506, or whatever. All right, so hopefully that helps you with answering a two-dimensional question in the assessment 3, and also if it appears in the exam, right? One more thing to help you with the answering question number 8. If I look at each entry, entry 90, this is a matrix. If any of you have studied mathematics, this is row 1, column 1. You can think of it like that. Row 1, column 2, row 1, column 3, row 1, column 4, row 1, column 5, row 1, column 6. All right. This is row 2, column 1, row 2, column 2, row 2, column 3. Marianne, tell me when you get it. Row 2, column 4, row 2, column 5, row 2, column 6. Okay. Marianne, tell me when you get it. Row 3, column 1, row 3, column 2, row 3, column 3, row 3, column 4. Sisonka, tell me when you get it. Marianne, I just want you to talk. Row 3, column 4, row 3, column 5. Thato, tell me when you get it. Row 4, column 1, row 4, column 2, row 4, column 3, row 4, column 4, row 4, column 5.
I think they get it, sir.
Thank you. Thank you, Thato. Thank you, Sisonka. Marianne. See, Marianne wants me to continue, Thato. Sisonka. Marianne, we lost
Yes,
you.
sir.
Right, okay, I'll get it. So that will help you in question number 8. Question 8 says, int scores 3, 3, 1, 2, 3, and they want you to sneeze. Okay.
Please.
Okay. That is in a lecture. Right. So if you look at, they want to, in question number 8, what happens in 1, 2, 3, and in the value stored in score, you need to work it out like this. All right. Are you cool with question 8?
Yes,
Question, all right, so let's leave that alone. We can answer. Right, question 13, passing an array allows the computer to pass the address of only the first array element. Yeah, right. Consider 14, I can say that. Question 16, from what we've done today, you should be able to answer question 16, or even if it is means that you write out or type out what I've done, right? 17 also talks about arrays. Question 18 talks about a 2-dimensional array. This time the values are given, so you don't have to worry about that. They say, which statement will create a 2-dimensional array called scores with 3 rows and 2 columns, where each element has the initial value of 100, right? So that's question 18. Question 19, arrays in C++ are passed automatically to functions. How are they passed? Are they passed by value? Are they passed by reference? Are they passed by actual parameters, or are they passed by formal parameters? This is in your study guide. I'm not going to give you the answer, it's there. But if I noticed in what had happened here, in line number 36, I'm passing across an entire array. I'm passing it across there. Did I have a reference parameter in front of it? Did I have the ampersand sign there in line number 7? Sisonka? Thato? No, I didn't have it there, right? But what happened in display? I was able to access those values and display it. So that's what they're testing you in question number 19 of the assignment, right? Let's look at question number 19. You can answer that one. Question number 20, you can also look at that. In 21, 22, 23, they talk about strings and substrings. We'll talk about that one next week. Oh, there's length and size. Which statement determines the length of the string defined below and places the value into number variable, right? We'll talk about those things next week, or if you have any questions as well. With that, it's 1:05. I'd like to stick to about an hour and a half. If there's no other questions, oh, this looks pretty cool. Doesn't it look pretty cool? Doesn't that look pretty cool? I think I'm going to take a photo of this and pass it and put it into my, where's my snipping tool? Snip SN. Right, so let's take a picture there. Let's take a picture of that one. And I'm going to say thanks to Thato. Copy that. Control V. Thank you. THATO. Is that how you pronounce it, Thato?
Yes, sir.
Right. I mean, that's how I spell it.
Yes.
Thank you, Thato, for calling out the noise values from page 372. Luckily, you did not make a noise. How's that for a sense of humor? Oh, Marianne doesn't think I got a sense of humor. It's okay. Right. Okay. Are you cool? Oh, maybe what we'll do is I'll also copy this, copy that, Control C. Then I've posted it into the chat. Yay! So we got some stuff to chat. And make sure that you like my chat post in WhatsApp. Okay, Thato, Marianne, Sisonka.
Yes, sir.
Where's
Yes,
everybody?
sir.
Right. Okay. Can we call it a Saturday?
Yes, sir.
Right. Where's my robot voice?
This meeting has been completed.
Thank you. Let me stop the recording now and